Here we go. Take just a second for that Elmo to come on. We'll be ready to rock and roll. Just waiting here. Oh, dang it. Don't like that. Come on, pick up that Elmo UV camera. Okay, now we'll see if it'll pop up. It should pop up any second here. It's coming, I think. We'll find out real soon. Here we go. So find the inverse. Remember, inverse means inputs become outputs and outputs become inputs. So you could rewrite this as x equals e to the f inverse of x minus 2. How do you undo an exponent? ln. So we take the ln or log, but since it's e, natural log or log base e is ln. That undoes it. That's going to give us f inverse of x minus 2 equals the ln of x. Add the 2 over, and there's your inverse, ln of x plus 2. Find the inverse of this function right here. Again, so again, right here, I would take my inputs, making my outputs, outputs making my inputs. So therefore x equals 2f inverse of x cubed minus 5, so I would add 5 first. That'd be 2f inverse of x cubed equals x plus 5, divide by 2. Then you're going to have to take the cube root of that whole thing. So f inverse of x is going to equal the cube root of x plus 5 all over 2. Done. It says the temperature is given by this equation when the temperature of the coffee is above. When is the temperature of the coffee above 150? So in other words, when is this going to be greater than 150? So we can take out our calculator, we can turn it on, we can then go 72, y equals, make sure, oh, look at my calculator, I'm in R, so I've been plotting things that are polar. I need to change it, so I clicked on mode, come down to function, hit enter, take me back into a function mode. Now look, now I'm in y equals, so now I'm going to put in 72 plus 118 second, ln gives me e to a power, negative 0.93x, and that's that one. Then in the other one I want to put in 150. Now understand, by doing so, this is a y-intercept of 150. So when you hit graph, a good chance you're not seeing anything here because your window needs to open up. You need to have your y max at least 150. I'd say maybe go to like 160 just so we can see it a little bit easier. And I'm thinking my x max, it's going to be out there a ways. So let's go maybe to 50 and just see how that looks. So there's the one graph. There's the other. Oh, right there. I got to find that intersection right there. So I go to second, trace, number 5, hit enter, enter, enter. The calculator will think about it and it'll spit it out. So when will the temperature be above 550? After 0.445. Oh, so wait a minute. The temperature is going down. So when is it above 150? Before that. So between 0 and 0.445. That's when the temperature is above 150. After that, it drops below 150. Make sure you answer the correct question, guys. Answer the correct question. Okay. Number 51. A company produces sells chili powder. Here's their profit, and it's in dollars. Which numbers of pounds chili powder is the profit decreasing? So if I were you, I'd come to my calculator, and I would go and I would clear out what I got there. So then I would type in this equation right here, so which is 48x plus 1.4x squared minus 0.05 x to the power of 2.8, come down, minus 270. Now let's go ahead and graph that if we can. It's a little weird. Maybe let's zoom 6 a little bit. See if we can see a little bit more of this graph. A little less, I don't know. Maybe we need to open up even more. So let's go ahead and open it up. Let's go to, oh, there's something's coming. Looks like it's graphing still. So here we go, let's go to window. So let's go ahead and open up a bit. X min, let's have our X min go to like negative 100. Our X max, let's make it go to 100 by tens. Then let's go Y min negative 10 seems okay. I think Y max, we should probably have it go up higher. So maybe let's have it go up to 100 just for check. Let's graph and see what we get. So, okay. Is our line going up? Looks like this thing is, oh, now it's coming down. So sometimes, somewhere, it turned and started coming back down. Okay, so we need to open up that window and see a little bit higher up. So the Y max, let's go up to like maybe 250. Let's try that out and see if we get it. Okay, so it's coming. We're going to see here maybe in a minute. Come on, big dog. Oh, baby. Up even higher than 250. It's going to come back down right here. You're going to see it. Boom. So let's come back to window. Let's go up to like maybe, I don't know. Let's go up to 1,000. See how that works. So here we go. It should come up. See if it goes up, how high it goes up from here. There it is. Ooh, we're getting closer. We're getting closer, but still it's up there a ways because it still took a while. Okay, let's go to the window again. Maybe let's go to 5,000. Let's try 5,000 and check and see what that looks like. Sorry guys, takes a little while sometimes, huh? So, it should be coming up here. There it is. It should turn. Okay, perfect. So we just need to find that max height right there. Let's go to second, trace, and we want to find the max. So it says, are you to the left of it? So it says Y is 339, X is that. So yeah, now we gotta get clear to the right. Here it goes. We're working our way to the right. There we go. And now it's decreasing. It's going to be decreasing from 58 on. So it's going to be decreasing from 58.358 up to infinity. Stick a fork in it, you're done. Local company, age is all okay. Our last stage is approximately normally distributed. So if I were you, I draw a normal distribution curve. It says the mean is 35. Standard deviation of 5. 1, 2, 3, so that's 40, 45, 50, 30, 25, 20. Remember your percentages. 13.5, 13.5, 2.375, 2.375. Now, estimate the percent of new employees that are at least 20. So it'll be from here on. So almost 100% will be just this itty bitty piece right out here. So that'd be approximately 100% would be above 20. If you were to choose 2 new employees at random, most probably his region would be no more than 30. So it'd be just these two added together. So that would be 15.875%. So I just add, because no more than 30 would be from here to there. So I just add up those two. And there you go. Okay, 54.
So the root of the top is 2x. So that limit is 4.
It's a busy day. So it says they have a passenger jet located bearing at 45 degrees east of north. So that would be,
we know f is 1.
East of north would be this way, 45 degrees. And then it says that.
So then you get that the limit.
And then it says there's a private plane located 34 degrees east of north. So that'd be this way. Okay, that's 34 degrees. and it says that it's 14 miles. It says 14 miles from airport is 22. Question is, how far apart are they? Now, if this is 45 and this is 34, that means this angle right in here has got to be 11. So to find this, I'm going to use law of cosines. So I'm going to say c squared equals 22 squared plus 14 squared minus 2 times 22 times 14 times the cosine of 11. Then I just take the square root of that, and that'll tell me the distance there is. So I go to my calculator, I turn it on. I'm going to just take this equation right here, plug it in, second square root, 22 squared, oops, minus 14 squared. Sorry, it shouldn't be minus there, that should be plus.
So to prove k is continuous, then you have to show that the left limit equals the right limit equals
Minus 2 times 22 times 14 times the cosine of 11. Make sure that you are in degree mode. So I'm going to come on mode. I'm in radian mode, so I need to change it back to degrees because that 11 is in degrees. So I should redo it. Oh, and I only did a 1. I need to do 11. I don't want to graph you, silly goose.
Right? Like, and even if students know that's true, right? Like,
Sorry.
how do they know?
Here we go.
And if they try
There
to
it
say
is.
words, they're probably
So they are
so,
8.679
so then these
miles
things-
apart. There it is. Finally
So
done.
then
Triangle has two sides measuring 10 and 12. And it says the angle opposite the 10 each side is 50 degrees.
and then you also
So
have
here's a
to
triangle.
equals 4.
Has sides measuring 10 and 12. It says opposite the 10
So I'm
is
like,
50
okay,
degrees.
points.
So we could take the sine of 50
When I saw the
over
question,
10
I was like,
equals the
okay,
sine
we
of
can, like,
x over
justify,
12
like,
times by 12.
words, but how do you, like, notate that?
Then we can take the inverse sine of that.
That's how you have to notate it.
Take the inverse sine of that. So therefore we get x equals, and now I should plug in my calculator, the inverse sine of 12 times sine 50, and in parentheses, divided by 10.
Mostly I do.
It's going to be
This is
66.817.
one more like, hey, these are,
So
they're gonna throw something at you and.
understand
you know,
here
and
that
the lab with
this could be an
your
ambiguous angle.
I don't
So
know,
180
like,
minus
hey,
that would be
maybe
like
you don't
114.
It says me
approximately
hiding, so what do I know about me hiding?
113.2.
Why should you, like, have to be minus that big?
So this could be that, or it could be 113.2.
If you get that point,
Now,
that's what
if
I'm
it is
doing.
66.8,
Oh, I know,
add it to
I-
50,
that's fine. Okay,
66.817 plus 50 minus that from 200 or 180. That would tell you your other angle up here is going to be 63.183. So then you could take the sine of 163.183 divided by x. That would then equal sine of 50 over 10. So the sine of 50 over 10. Notice what you want is on the bottom. Take both sides and flip it. That would then give you x over sine of 163.183 equals 10 over sine 50. Multiply by sine 163.183. Those will simplify, and we would get this x, which is this side down here, equal to, and I take my calculator, I just take 10 times sine 168.183 divided by sine of 50. And I get 2.673. Now that's kind of a problem to me. Because this is the biggest. Oh, that's sine of 63 or 163? I don't even know where I did that. Sugar boogie, guys. Hey, give yourselves a full class ticket on that one, because I think I totally messed that up. I don't know. My mind is in a little bit a little crazy right here. A little crazy. So you know what? I'm going to stop right now and I'll redo 55 on the next video. So it'll be coming at you, okay? So just hang tight. Oh my gosh. Oh, cancel. Thank you. I can't handle that.